Are going to continue classifying two-dimensional figures, and let's get right into it with our warm-up. It says name two categories each shape belongs to, and then we're going to see if one is a category, is one a category, a subcategory of the other. And the way to for me to do that simple is I'm going to name the category first, and then I'll do the subcategory right underneath it. So let's start with figure one. Figure one, as we know, is a triangle. And remember, subcategories add another detail or a little more specific. So if I look at this triangle, I can guess that all three sides are the same. So the subcategory is an equilateral triangle. And I'll just put tri here like that. Over here, now your first instinct is probably to call that a square. We could do that, but it's also by definition, this is a rectangle. Rectangle has two pairs, has opposite sides that are parallel and four right angles. But we also know if all four sides are equal, that makes it a square. So there's that. And for this one over here, we're going to keep this really general. This is a polygon. Polygon is just something is a shape with all straight sides and it's enclosed. And if we want to get very specific, we've got 1, 2, 3, 4 sides. So that subcategory can be quadrilateral. So in doing this warm-up, it gives us a little review and also shows the connection on how a shape can be categorized and in different ways. All right, so this lesson will start on page 591. And it wants to sort these shapes A through G right here in this Venn diagram. So we want to start with our most general shape and then go forward. So what I'm going to look at first are these two shapes right here, because they look like the odd ones that are not like the other ones. I do notice that every single shape up here has at least four sides. So what I'm going to do here is our most general group is quadrilaterals. And we're going to do A and G. So these two are done. Then we've got these other circles here. I need to put something in that next space. Looking at what's left, B, C, D, E, and F, I know all of those are, I know I've got this one right here. It's a parallelogram. And that's B. And this leaves me with these shapes at the end here. And notice we've got these two Venn diagram, these two ovals that are overlapping each other. That means something here in the center is going to have the same with both sides. Let's identify the rhombus, which is this one right here. And then we have these rectangles right here. So rectangles. And that is C and F. And that leaves us with square. Let's go back with red here. And that square is letter D. So you can see how with this Venn diagram, these can, they're all quadrilaterals. Every shape up there is a quadrilateral. Well, A and G are, but technically all of them are, but A and G are just quadrilaterals. Parallelogram, B is a quadrilateral, but also has parallel sides. And then the rest are parallelograms that are either a rhombus or rectangle, and then one has This square D has features from both rhombuses and rectangles. That's why it's in that little area where there's some overlap. So we can use this information later on to help identify certain parts. All right, let's turn the page. And we're just going to go over a couple things here. This table is going to help us out with the notes that are on the right-hand side on page 593. We're going to come back to this, but it shows all 5 of those categories, and their properties are listed here on the left. And each X indicates what property these things have. So we'll come back to this again later. And for this one, this is an unfinished Venn diagram and very similar to the one that we made. In fact, it's exactly like it. It wants us to write the remaining category names and letters for figures C, D, E, and F. So we know from previously that the rhombus, which is E, we had rectangles, that was C and F, and then the square, which is D. All right, let's start these notes over here on the right. Gonna have to come back to that table a couple more times. Look at the quadrilaterals column in the table and the placement of shapes A and G in the Venn diagram. Why are shapes A and G placed in the outermost oval? So the answer, because quadrilaterals are the most general. Now, what we mean by that is if you look at the quadrilaterals column in that table, notice quadrilaterals only has one X. So there's only one property to it. The rest have 3 or more X's for that. So they've got more properties. The quadrilaterals have the least. Explain how the Venn diagram supports this statement. All parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. This is because that parallelogram oval is inside the quadrilateral oval. So the fact that one is inside the other shows that and supports this statement that parallelograms are quadrilaterals, but not the other way around. Let's look at the table. Which categories share all the properties listed for parallelograms? That would be rectangles, rhombuses, and squares. And you can just simply look at the column for parallelograms. It has those top 3 checked off or X'd out. 4 sides, 2 sides of parallel sides, and 2 pairs of sides of equal length. If you look over, rectangles, rhombuses, and squares are the only ones that have all of those with an X in it. And how is this shown in the Venn diagram? So for those 3, their ovals are inside the parallelogram oval. Look at the table. Which properties are not shared by rectangles and rhombuses? So if you look and compare them, notice those last 2 properties are the ones where they are not shared. Rhombuses has 4 sides of equal length, but rectangles doesn't. Rectangles has 4 right angles, and rhombuses doesn't. So it is 4 sides of equal length. And the other one is 4 right angles. Houses shown in the Venn diagram. This is shown by their ovals overlap. And that overlap is where you know that two different things are share the same properties. Look at your Venn diagram. Y is shape D inside all the ovals. And the answer is the square has all the properties of the others. And for number 6, we can skip that one since we're not together as a class to discuss. All right, so it won't take too long. Mathematicians define trapezoids in 2 different ways. So trapezoids are good to know because that's on your IXL today. They're quadrilaterals, which means they have 4 sides. And they have exactly 1 pair of parallel sides. So only one pair of parallel sides. And trapezoids are quadrilaterals with at least 1 pair of parallel sides. So write exactly 1 pair or at least 1 pair to show which definition of trapezoid was used to make each Venn diagram below. So we've got this one and this one here. The one on the left, this represents at least 1 pair. That shows that second one. This Venn diagram on the right shows that top statement where it's exactly 1 pair. Next up, number 8. Sort these shapes in the Venn diagram based on properties of having parallel sides and having perpendicular sides. So let's set that up. Parallel sides, perpendicular sides. Now perpendicular, when they say that, that's something like that. Parallel sides, I can represent like that. So let's do, I know A, C, and E have parallel sides, A, C, and E. And then I know D has a perpendicular side, but I also notice that B and F, they've got parallel sides and perpendicular sides. So I'm going to have to place those right here in the center, just like that. And lastly, for number 9, which definition in problem 7 lets you classify shape A in problem B as a trapezoid? It's this phrase right here. At least 1 pair of parallel sides. And there you have it for your notes. So the IXL, I'm giving you, again, two IXL assignments to go to 70%. And these shouldn't take too long. We focused on triangles last time. This time we're going to identify parallelograms, and we're going to identify trapezoids. So for AA5, just look for a figure that has at least 1 pair of parallel sides. And then for the 6, trapezoids have only 1 pair of parallel sides. So there's a difference between the two. Just make sure you're doing that.